The biggest thing that I do on these problems is that I set them up as before and after, right? And so all my pictures are very before and after style with a dotted line down through the middle. So I drew the bowling ball moving forward, and then I drew the pin not moving. And I separated those things as an after picture where I have the bowling ball afterwards, right? Moving forward at some unknown speed, v prime, as the question. I call this object 1 and this object 2 instead of using letters, right? You can use letters. You can also use subscript words, right? If you want to write the word bowling ball or write the word pin underneath it, that's also fine. Whatever is most useful. I like to just do 1s and 2s. What was that? Is that a hiccup?
No, it was a sneeze.
I know that the pin acquires a forward velocity v2 prime of positive 16.5. Right? And I know that the original velocity over here of the bowling ball was positive 7 meters per second. This is based on FOR going this direction as positive. I know that the initial velocity of the pin is 0. And then in terms of organization, I drew the picture, I listed the velocities first, and then for argument's sake, rather than listing them directly on the objects, I like to just list them like this. M1 is 6 kilograms, M2 is 2.5 kilograms, M1 is 6 kilograms, M2 is 2.5 kilograms, right? Keeping it all nice and neat in a nice organized fashion. Generally, the masses will stay the same. So, P equals P prime is the systems, right? And so then I've identified in the system that I have 2 objects. So I call this P1, I call this P2, P1 prime, P2 prime. Sorry, this is an equal sign.
Why do you make both of the terms prime? When you set it up, the equation, you get P prime equals after.
Yeah. Oh, sorry, I wrote prime twice. My mistake. Sorry.
Okay. I should know.
No, yeah. P equals P prime. The momentums before equal the momentums afterwards, and then it's just a matter of substituting in that P is mv, right? And so this is m1 v1 plus m2 v2 equal to m1 v1 prime plus m2 v2 prime, right? If you organize according to the way that I've organized, then all of these things transpose directly in. If you make a list somewhere else, that may work for you too, right? But the key here is keeping these things organized. I tend to stick to P equals P prime and then think about the objects I have and then put the formula in. This is the same practice I did when I did energy, right? That way I'm building the equation that I need to solve. After I plug in all these numbers from above, I got a V1 prime equal to 0.13 meters per second. This one is an F4. This is an actual experiment. This is an actual experiment that they did at the Sandia National Labs. We have a jet flying at some ludicrous speed, right? V1 is the question. And then they have a testing wall. This testing wall is tricky though, right? Because the concrete barrier is actually on top of a frictionless air track, right? It works just like an air hockey table. So you can think of this as almost being on wheels, where this is going to move, right? It's not moving right now, but it can slide, right? That way, I know that the mass is the only reason why it's slowing down and not friction. Because if there was friction, then we'd have to include that as a non-conservative energy loss. And that wouldn't be a momentum, so it would throw off our calculations. That's exactly right. So I know that V2 over here is 0, right? So then in the after picture, what I have is I have a smashed plane, right? And a slightly damaged wall moving as one new object, right? They're stuck together. What I tend to do is, since I want to distinguish the difference between 2 objects and one new object, I usually identify that as a new subscript. So I'm going to call this V3 prime. Exactly. This is the one that's 8.41 meters per second. Okay, so if you did this as V1 prime is 8.41 and V2 prime is 8.41. You're exactly right, right? All I'm saying is that V1 is V2, and so I'm calling it something that I can just use one variable, V3. You can call it just V1 prime or just V2 prime. That works also, as long as you're organized in the next step, right? Because when I go down here, oh, sorry, and then I would list all the masses. Mass 1 is 19,100 in kilograms. Mass 2 is humongous, 469,000 kilograms. And then they're the same on this side. So on this side, what I would label is I'd say M3 is the sum of 19,110 plus 469,000.
You mean V3? But if you did do
M3.
V1 prime,
Right, the mass of this is the jet and the wall stuck together.
you can still separate them into.
Uh-huh. Yeah. So if I think about it as P equals P prime, in the initial condition, I have P1 and P2. In the final condition, I only have one object. That's why I call it P3. Right? You may have P1 plus P2. That's fine, right? But just make sure you recognize that this works either way. Okay, so then what I did here is I said M1V1 plus M2V2 is equal to the sum of M1 plus M2 times V3 prime. I like to do all of this work right in my math. So this is the 19,100 times V1 plus 0, because the wall's not moving, equal to this sum up here, whatever that is, 19,100 plus 469,000 times 8.41. You can go back and look. If you did it as separate objects, this would be 19,100 mass 1 times 8.41, right? Because that's how fast the plane is moving after it crashes, plus the wall moving, 469,000 times 8.41. All I'm doing is factoring the 8.41 out beforehand. So then I multiply and add all these numbers together, and then I divide by 19,100, and I got V1 to be approximately 215 meters per second.
I got that. I got it.
Tubby and Chubby are the Busch Garden bullies. They hang out at the bumper cars. Tubby and Chubby like to harass the other kids because they're big, which means that their momentum is large when they interact with other people in the bumper cars. So we have Tubby and Chubby moving forward. Let's call that V1 at 10 meters per second. And then poor Melinda is all by herself. Right? She's got... Yeah, because it feels like it should be, right? And her velocity, V2, is 0. Then after the collision, they bump Melinda's car, which is still sitting still. Melinda has this mass. After the collision, the twins continue forward, right? So these guys are so massive that they don't get knocked backwards. They just slow down. So V1 prime is 4.12 meters per second. And then the question is, what happens to poor Melinda, who's probably ending up facing this way, moving that way, at V2 prime? So let's talk about it, right? If this is my frame of reference, FOR is forward is positive. This is positive 10. This is positive 4. And I'm expecting a positive answer because if she might have been moving, she might have been moving in a negative way, and then she got knocked back around. So in this particular example, we don't know that because she started at 0. So then the tricky part here is the M's. M1, right, is Tubby, Chubby, and a bumper car, right? And so their combined mass is 200, and the car's mass is 100, which makes their total mass 300 kilograms, which, unfortunately for Melinda, is a lot. I think she's only about 125. Right? Careful.
It's already in
100 plus 25 is 125. Yep, I just didn't write it the same.
There was my mistake.
Yeah. Her total mass is 125. Their total mass is 300. On this side, they stay the same, so no one jumps off or anything. But just because there's such confusion, I like to rewrite it. M1 is 300. M2 is 125. Right, before and after. So then I have P equals P prime. I have P1 plus P2 equals P1 prime plus P2 prime.
Is there always two objects?
No. There are always two objects except for number 5.
Great.
So then, of course, M1V1 plus M2V2 equals M1V1 prime plus M2V2 prime. Okay, so then put all the numbers in. This is 300 times 10 plus 0 equal to 300 times 4.12 plus 125 times V2 prime. I got V2 prime equal to 14.
Yes. Get this red pen.
Valentina,
Is this a negative number?
Valentina is 15 meters away, right? When something tragic happens to her, her cable breaks, right? And so now she's stuck in space.
What is happening here? What is this drawing?
And it's just her and a camera. This is clearly a person with a space helmet on and an oxygen pack holding a camera. Clearly.
Obviously.
All right, before anything happens, though, I'm calling her V3 because it's two objects stuck together. How fast are they moving?
They are not.
They are not. She is literally stuck in space. So then afterwards, we expect that she will hopefully be going this way,
Her head looks like an olive.
right? That's the speed we're trying to find, V1 prime, right? Obviously, I know it's this way because I drew the ship, right? I know where she wants to go back to. That's really helpful. So then I know that she probably chucked the camera
Out the other way.
this direction so that she could get there, right?
I hope it wasn't a nice camera.
I'm sure she can get another one. So I know that M1 is 68.
That's like
I know that M2 is 2 kilograms, which means that M3 is what?
M3 is
70 kilograms. Because M1 plus M2 is M3. Very good, AG.
Did I do that? I don't think I did that. I don't know.
Right. Okay, so P equals P prime. I have P3 equal to P1 prime plus P2 prime because I have one object splitting into two.
Oh, that makes sense.
But P3 is 0 because nothing's happening. Very good, Lizzie. So then on this side, M1 V1 prime plus M2 V2 prime. M1 is 68. V1's prime is what I'm trying to find. 2 times 12. Now again, I kind of instinctively already put that going forward is positive because I made this positive 12. Right? And so this is positive 12, and this one will probably be negative. So I subtract 24 and divide by 68, and I get a V1 that's slow, but I'm not upset because I'm moving towards a spaceship. Negative 0.35 meters per second, or approximately equal to 0.4.
Like how you did, but I still got that.
I did that too. I got
Good. So now I know that in this section, right, she is moving towards the spaceship at 0.4 meters per second. I also know that she has to go 15 meters, but she starts here and actually goes back to the ship, right? And so D is actually negative 15, which is how I get rid of the negative time. Right? And so now I know that V equals D over T. I use this formula because in space there's no air,
So no acceleration.
so no acceleration, no deceleration, no friction. right? The force happened over here when she threw the camera, but now that she's just floating through space, she's just moving at a nice, slow, constant, stargazing speed. And so negative 0.4 equals negative 15 over t. So t is, what is it? 43 seconds. So what I have is I have a radioactive nucleus. They generally look like circles, but I'm going to cloud it up a little bit. So it looks like a cloud, right? The nucleus looks like this. Initially, it's at rest. So we'll call that, I don't know, v equals 0. In the after picture, right, I have the nucleus, what's left over, an electron, and a neutrino. So I have 3 objects instead of 2. The electron and the neutrino are emitted at right angles, right? And so I'm going to go ahead and draw that as up and to the right for my picture. So I'm going to say that the electron goes this way. E minus is the symbol for an electron. And I'm going to say the neutrino goes this way. Neutral is the symbol for a neutrino. Nu, as in the Greek letter nu. What I have to imagine, right, is that the total momentum is 0 beforehand, which means the total momentum must be 0 afterwards, right? We've talked about how to add vectors together. These two things have momentum, right, along the given arrows that I've drawn here. Momentum is the vector in question, so the actual math of m times v has already been calculated, right? Because it says the momentum is blah, 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 9.3 times 10 to the negative 23 and 5.4 times 10 to the negative 23. That is m times v, right? So we're not doing that calculation. All we're caring about now is the vector analysis, the direction characteristic, right? So what I have to think about is that the total momentum must be 0. So I have a p1 prime that goes up, and I have a p2 prime that goes right. In order to cancel out up, I'm expecting that p3 is going to have a component that goes down. And in order to cancel out p to the right, I'm going to expect that p3 has a momentum that goes left. Left and down is a diagonal left and down arrow, right? Like this.
Oh, exciting.
Right? P3 prime is the question.
I got the dice probably wrong every time.
This is not the dice.
Okay, so here's what it looks like in the setup, just like we had before. P equals P prime, where 0, no matter how many objects there are, is equal to P1 prime plus P2 prime plus P3 prime. Now I've kept the arrows on there because these are vectors, which means that if I just put numbers in there, I'm going to get it wrong, right? The vectors tell me that the direction matters. So what I want to take a moment and think about is what this plus this is, right? And so I'm going to think of that as a separate analysis off to the side. Now later you can do this directly on the problem if you want, right? But if I have P1, right, prime as up and 9.3 times 10 to the negative 23 kilogram meters per second. And I have P2 prime, right, as right equal to 5.4 times 10 to the negative 23 kilogram meters per second. I need to add these two vectors together, right? How do I add vectors together? No. We make a triangle. Exactly. All right, so look, because this is a skill that's very, very useful, and we have been using this indirectly, I'm going to draw the first vector, P1, and then without moving from where I finished, I'm going to draw the second vector, P2. Right, because I want to be able to say them in order, up and to the right, up and to the right, because that tells me then that the vector combination is from where I started to where I finished, which is a direct line that goes like this. So if we can figure out where this, let's just call this P4, right?
P3 be just the opposite.
P3 would be the opposite of that. Exactly.
Wait, why can't we to the right?
Oh, because it's I get it.
Why can't we draw it down? Oh wait.
So we could, if we wanted to, we could say that the opposite of this plus the opposite of that is directly P3. But if I'm looking at the analysis, right, these two are already these numbers, and then this happens to be the opposite of those two things added together. That's where I'm putting it all together. Does that make sense? So what that means is that if I can find this vector by doing a squared, b squared, c squared, and find this angle, theta, then if I add 180 degrees to that angle, right, then I will be able to find P3 prime, because that would be this angle going out like that. That make sense?
What would we call that other angle? Phi? Psi?
So
What would we call it?
I called the one down here for P4 theta. This from here to there is 180 degrees. And so then I would call the direction of P3, phi, as being theta plus 180 degrees. So remember that the horizontal one is P2, right, which is 5.4 times 10 to the negative 23, and the vertical one is 9.3. So if I do 9.3 and 5.4 squared, add them together and take the square root, I should be able to get whatever this is, P4, which I have as 10.8, right? And so now I have a triangle that looks like this, where this is 5.4, this is 9.3, and this is 10.8. And then I can find the angle here by either finding this angle and then taking 90 minus it, or I can do sine, cosine, tangent, where I rebuild this triangle by saying it backwards. To the right and up builds the same triangle where this is 5.4, this is 9.3, and my answer is still 10.8. But that allows me to find theta inside here, which I have as 60 degrees. My final answer is P3 prime is 10.8 times 10 to the negative 23. I just kept the negative 23s off when I did the math over here. Only if they're the same. So this is kilogram meters per second at an angle of phi, which is 60 plus 180, which is what, 240 degrees. So in the triangle, in either one of these pictures, I can find theta, which is down here in this corner, because I know the hypotenuse is 10.8, I know the side opposite is 9.3, and I know the side adjacent is 5.4. So I can use any trig function. My favorite is tangent. So I say tangent of theta is equal to the opposite, which is 9.3, divided by the adjacent, which is 5.4. Phi,
Spots going on there, and I don't know which
okay,
one's
remember that phi is the overall direction of P3, right? This is P3 down here, P3 prime. Phi is measured on the compass rose from 0 degrees around counterclockwise, always. So if I measure from 0 all the way around to where this vector is, that's phi, which is theta plus 180 degrees.
Okay, so it's from...
It's always from 0. Okay, real quick before you leave, one quick thing. Ballistic pendulum, which is number 6.
What's the answer?
The bullet is really small. The block is very big. Sorry. Then afterwards, the block and the bullet are one object. And then from here to there, they slow down, right? And then over here, there's still one object, except that their final velocity is 0. From this picture to this picture, you should be able to do conservation of momentum. From here to there, you should be able to do work exactly like a car hitting a wall. It has kinetic energy, and then it doesn't. Where does it go?
Thermal.
Into thermal work, which is friction acting over this displacement.
What we do F.
Put all that together, and you should be able to solve this problem. I got a final answer of 660 meters per second.
I got 604.
That's pretty close. So make sure that you've added both masses together on the second half, and then you'll be able to take it from there.
Way different way.
Would you get F of F equals
4?
4? Okay.
Sure did.
So then what do I do after that?
So then F of F is the force for the work,
Okay.
and the distance is 7.